Hello there, Algebras, and welcome to your Chapter 1, Lesson 5, Notes Day 2. So today, we're going to take what we did in solving our rational equations, and we are going to compare how we solve rational equations to how we look at and solve proportions. We're going to figure out how we know when we've got just a regular old rational or fractional equation versus when we have a proportion, okay? So let's just kind of review. When looking at two fractions, we do have a common denominator we look for, or a LCD, a least common denominator that we want to be looking for. So when I'm looking at having 4 and 3, what could be their LCD? What could they both multiply to become? So 4 and 3, well, if you actually multiply them together, you get their LCD. Their LCD is 12. Look at 3 and 6 and x. So if x is in a denominator, we do want to make sure we are stating that x is not equal to 0 when we go to solve. Okay, so just be mindful of that. That's kind of in the back of our heads. We know we can't have a 0 in a denominator, so that's just in the back, like we're thinking about that. But also when we have an x in a denominator and we are trying to find our least common denominator, or our LCD, we know that x has to be one of the multiplied pieces giving us that LCD. Now, that means that we think about the other two numbers and we think about those as what do they both multiply to become. And so when you've got 3 can multiply to become 6. Right? So always kind of look at that biggest value and see, okay, can the other one multiply to become that? Yes, that is the LCD. So 6x is going to be my LCD here. All right, and when it is that you have an x in the LCD, that's when you do want to make sure you state that x cannot be equal to 0. Because when you have an x in an LCD, it means you have an x in a denominator. That value can't be a 0. So just kind of a reminder of what that is. Now, a proportion is when you have one fraction. So one fraction set equal to one other fraction, and that's it. Proportions can get solved by cross multiplication. I do not need to find an LCD. I can if I want to, but I don't have to. Okay, that actually would get taken care of by my cross multiplication. That takes care of the LCD proportion, or portion of what you're trying to do. Versus 1, 2 fractions, right? Adding up on the same side. This is not a fraction set equal to another fraction. And then we're equal to some number. It could be another fraction over on the other side of the equal sign for all we care. But if you have more than one fraction on the same side of an equal sign, you do not have a proportion. You must find an LCD. Okay, so that is what our difference looks like in the two types of equations. Now let's look at some practice on solving the two different types of equations. So let's remind ourselves how to solve a proportion. One fraction equal to one other fraction. Okay, the denominator of the first fraction multiplies by everything in the numerator of the second fraction. So 5 times x, 5x. 5 times -3, -15. Now you're done with that side. Bring down your equal sign. And now we do this on the opposite side. The denominator of the second fraction multiplies by everything in the numerator of the first fraction. Cross multiplying. 6 times x is 6x. And now all we have to do is get all of our x's on one side of the equal sign. So since we have all our numbers right here in this -15, that would mean let's subtract that 5x from both sides of the equal sign. So subtract that 5x over, I'm left with -15 equals 6x minus 5x, or 1x, or just x, all by itself, and I am done. X equals -15. One fraction set equal to one fraction is when I can cross multiply. multiple fractions on the same side of the equal sign with a plus or minus between them is when I have to find the LCD. So I need to find the LCD so that I can cancel out denominators and just use what's left in numerators. So let's see. The biggest value down here in denominators is 5. 3 cannot multiply to become 5. So then my next default to finding the LCD, what's 5 times 3? That would be 15. So let's take that LCD and multiply it by every single piece of the equation. So the 15 has to multiply by every single piece of this equation here. In the front of this, 15 over 5 cancels out to a 3. That's what gets multiplied through in the numerator. 3 times x is 3x. In the second piece, you've got 15 divided by 3. That cancels out to a 5 left over. 5 times 2x, bring down a plus 10x. Bring down your equal sign. Look over here. There is nothing that cancels out there with that because there is no denominator present. So we've got 15 times 5, which is 75 over here. Okay, great. So now we combine our like terms, right? So on the same side of the equal sign, 3x plus 10x is 13x equals 75. Ooh, doesn't look like this one is going to give us an integer answer because when we go and divide both sides by that 13, remember I taught you just the division sign and then you can divide by 13. Oh, we get a non-repeating, non-terminating decimal. Let's just round to the nearest thousandth. So we get that x equals 5.769. We know that there are more values behind that 9 in this non-repeating, non-terminating decimal. However, I think that's enough to get the point across as to what value x can be represented by. Okay. Just looking at those two differences. Look at number 1 as a practice problem. You have an LCD problem. How do I know? I've got one fraction plus another fraction on the same side of the equal sign. So, okay, look at the bigger of my two denominators. It's 3. Can 2 multiply to become 3? No. So now take the two values and multiply them together to get your LCD. 2 times 3 is 6. So I multiply every piece of the equation, sorry, that should be a longer parenthesis, by 6. And that does include anything that doesn't necessarily have a denominator. It's every single piece of your equation has to multiply by that LCD. It will cancel with denominators that are present. So what that does, that LCD only gets multiplied through with whatever's left over. So 6 divided by 2 helps me cancel this denominator out, leaves me with a 3. That gets multiplied by this entire numerator. I bring down 3x plus 3. Now I head to the middle where 6 divided by 3 is 2. That gets multiplied by this entire numerator, but that's just 2 times x, which is 2x. Now bring down your equal sign, and over here you've got 6 times 18, which of course gives us 108. On the same side of the equal sign, you combine those like terms. 3x's plus 2x's is 5x's, plus 3 equals 108. We need 5x's all by themselves on that side of the equal sign. I'm just going to scooch this up so I have a little more room. So we'll subtract that 3 from both sides. 5x equals 105. Now divide both sides by 5, and we get x equals, and we'll take our 105, and again, I'm sure many of you have done this in your head. Again, just trying to remind you how to use that graphing calculator, how to plug these in, how a fraction is a division problem, how you use that division button. We get 21. The beauty of the graphing calculator I'm using on the screen is the last button I pressed is still in red, so you can see where I have pressed buttons as I'm working. Okay? Now, number 2. You have more than just a fraction on this side of the equal sign. You have a fraction and a whole number being added up. It's not just a fraction set equal to another fraction. So this is again an LCD problem. But this time we have to state that x cannot be equal to 0. Why? Because we have an x in a denominator. And in fact, because all of the present denominators are an x, they are the LCD. X is the LCD. So what I do here is I multiply every piece of this equation by x. So that does include the spot where there is not a denominator for that LCD to cancel with. So every single piece gets multiplied by x. Now, in the front piece, does x cancel out with x right off the bat? Yep, there we go. We are left with just that 4. Here, there is no denominator for our LCD to cancel with, so we bring down that 2x to the next line. And here, again, x divided by x cancels out completely, and a 6 is left. So now, move that 4 to the other side of the equal sign by subtracting it over. Inverse operations, 6 minus 4 being 2. The inverse of multiplying by 2 is dividing by 2. We'll divide both sides by 2. We get x equals 1 as our answer there. Notice it was not 0, so we are allowed to keep that answer. We just had to not get our x value to be equal to 0. We can't have a 0 in a denominator. The whole world would implode, as we already know. All right. See if there's any proportions on here to practice, huh? Let's look at this next page. Oh, man. Look down that whole page. Look at that. Is there any fraction just set equal to another fraction? Nope. So, okay. Let's dive into one of the maybe more complicated examples that we have here, which let's take a look at 6. So let's zoom into 6 and see what on earth is going on here. Okay? So notice in 6, we have 2 fractions added up on one side of the equal sign, and we got a binomial going on the other side of the equal sign. So this is a potential complication. So let's focus on our denominators first. Do I have an x in a denominator? No. So I don't have to worry about x can't be equal to 0. Okay, my bigger denominator is 9. Can 2 multiply to become 9? No, because it's not even. Okay, that means let's multiply them together to get my LCD. 9 times 2 is 18 for my LCD, or least common denominator. That 18 gets multiplied by every single piece of this equation. So I'm rewriting so that 18 multiplies in all of the spots, including this whole other side of the equal sign. This entire binomial gets multiplied by 18. See that potential mistake? Make sure this 18 is out in front of those parentheses so that whole side gets multiplied by 18. Okay, so in the front over here, 18 divided by 9 is 2. That is what gets distributed by this numerator. 2 times 2x, 4x. 2 times negative 3, negative 6. In the middle, 18 divided by 2 is 9, so 9 gets distributed. So we bring down a plus 9x, and we bring down a plus 9 before bringing down our equal sign, and this entire LCD gets distributed here because there is no denominator for this to cancel out with. So we've got 18 times 4 back here, giving us a negative 72 back there. But before I can deal with that on the right, let's combine all like terms on the left. So I end up with 13x, and let's see what this is. 9 minus 6 is positive 3. Let's move our 18x to be with our 13x on the left. So I'm going to subtract that 18x over. I get negative 5x here. And let's subtract this 3 over to be with this negative 72, and we end up with a negative 75. Same sign sum. They're both negative, so you actually add the values up, and the answer just to that is also negative. Okay. Now, we would divide both sides by -5. And we get the x equals, so we end up with a 75 divided by 5. Since they're both negative, I already know that their signs cancel each other out, right? Negative divided by negative is a positive answer. So x equals positive 15. That was a great one to look at. Let's also look at number 7. Number 7 is another excellent one to look at. Okay? So let's zoom in on number 7. And let's say, okay, 1, 2, 3 denominators to have to deal with. Look at the biggest denominator first, 4. And make sure that they can't both multiply to become 4. Well, I don't see an x in a denominator, so that's good. I don't have to worry about x not being equal to 0. But can 3 become 4 by multiplication? No. 2 could, but since 3 can't also, you can't have 4 as your LCD. So now I am going to have to multiply those biggest two together to see what I get. So 3 times 4 is 12 is my LCD because 2 can multiply to become 12. Now I take that LCD and I multiply it by every single piece of the equation. Now be careful with this negative. That is going to be the key in this problem. That's going to be where the potential mistake is going to come in. So I'll show you that in a second. Oh, when was the last time we used y as a variable, huh? Good for us. We've got a different variable. So, in the front, 12 divided by 3 is 4 as our leftover. So 4 has to get multiplied by both pieces in the numerator. I bring down a 4y plus 8. Now here's where the trick could happen. Deal with the LCD being divided by the denominator first. What's 12 divided by 4? It's a 3 left over, but this negative means it's a -3 that gets distributed. So it's -3 times y is -3y, and -3 times +3 is a -9 that gets brought down. So be very careful on that. That negative in front means for both of these things in the numerator, that's getting distributed. And now, of course, on the other side of the equal sign, 12 divided by 2 is 6, and 6 times 1 is 6. Combine like terms on the same side. 4y's minus 3y's is 1y, or just y. 8 minus 9 is -1. That equals my 6. And so to get my y all by itself, we would add 1 to both sides. So y equals 7. Why don't we stop right here? We just did number 6 and number 7, but why don't we take a break? Why don't we take a breather and have you try number 8? So I would like you to pause this right here. Pause this right here. And then you try number 8. After you're done trying number 8, press play again, and let's see if my answer and your answer match up for number 8. Okay, so pause it. I'll see you in a sec. And we're back. How did you do? Where was the key potential problem? Right here. This needed to be a plus 30 that we got here because when we have this minus right in front of this part, this fractional piece in my equation, after your LCD has canceled out with your denominator, leaving you with a 10, it's actually a -10 that gets distributed. So it's a -10y, and -10 times -3 is a positive 30. That's where the big potential mistake would go. The second possible mistake would be when your whole fraction is negative, it honestly doesn't matter if the negative is kind of listed in the top or listed in the bottom, because remember, fractions are division problems. So there's only one negative present. Somewhere in there, one of those values will be negative, which means my answer is going to be negative. So as long as I came down with that -4, because I know that that negative is still present, that's just fine in that particular one. Okay? All right, algebras. Now it's your turn. You try our 5-1 homework number 2. See how you do. Remember, be on the lookout for where is our equation, where is our LCD or our proportion versus our LCD fractional equation, right? Keep this difference in mind right here as we are solving, okay? If it's one fraction set equal to one fraction, you can cross multiply. If it is any other combo of multiple things being added and subtracted on one side and then equal to potentially multiple things or one other thing, it doesn't matter. If there's multiple things being added or subtracted on one side, you cannot cross multiply. You must find yourself an LCD. Keep that in mind as you try that homework. Ask me any questions in person, and I will see you next time. Have a great rest of your day, Algebra Crew.